people to filter in, and then start at, I don't know, 3 or 4 minutes past the hour. Yeah, if you want to introduce yourself in the chat, feel free. Hey all, so there's a good turnout already. It's a couple minutes past the hour, so let's get started. Welcome to the second monthly Filecoin Green Meetup. I sure hope this is the date. I'm like 90% sure that today is March 1st. I'm Alan. I'm the team lead for Filecoin Green at Protocol Labs. And here's a few different ways you can get in touch. We are really happy to build this community and welcome more people into it to both examine the environmental impacts of the Filecoin network itself, work on ways to reduce and mitigate those impacts, working towards the goal of an environmentally positive network, and to build those tools in a way that they're applicable beyond Filecoin itself. And so here's what we're going to be talking about today. First, I'm going to give a quick update on Filecoin Green, talk a little, just sort of review what Filecoin Green is and what we're doing here, and give a couple updates on things that have happened recently. Then we're going to hear from Alex, who's at Seal Storage Technologies, which is a Filecoin storage provider that's being really forward-thinking in how they conceive of their environmental impact and make ESG representations. Then we're going to hear about synthetic locations of storage providers, some really neat work that Jim Pick is doing that is sort of at the core of how you take a distributed network that is permissionless, right? So people don't have to say where they are in order to join the network, and connect that network to renewable energy. So let's get into it. So I like to start this type of work by thinking about why we're here, right? And so this is called a Keeling curve. This is a graph of global mean temperature as a function of year, right? Going back a couple hundred years. And, as you can see, right, it is, temperature is increasing. It's not so great. And it is, it's caused by people, right? So these models show what the temperature would have been without people, right? Natural drivers only. And then they show what the temperature the models, expect we would have when you account for the fact that people are releasing all of this carbon into the atmosphere. And that lines up pretty well with the temperature that we actually observe. I think I showed this a month ago, and I mentioned, right, that you can take these temperatures and you can extend them back, not just, 200 years, but way farther, right? And they show the same trend, right? So this is what it looks like when you do that, right? So going back to year 1000, as best we can tell, the global average temperatures were in this relatively narrow corridor, right? And it's only been in the past 100 years or so that temperatures have really gone out of the regime in which our civilization adapted to exist within. So that's a spectacularly dangerous thing, right? And we need to act really quickly to reduce emissions globally to below zero, right? So we need to move toward having a negative emission society in order to counter this. So what's the role of Filecoin and Filecoin Green in doing this? Well, crypto is moving really quickly. It's one of the few industries that's moving at the time scale, evolving at the time scale that carbon reduction and carbon removal needs to evolve at. And we believe that Filecoin has a huge role to play in this because when people are making sustainability claims, right? So they are claiming that their company or their group meets some sustainability threshold. We really think that those claims should be backed up by unambiguous, publicly verifiable data, right? Crypto is all about public verifiability, and we think that Filecoin is the best place to store public data underlying environmental claims. And so Filecoin Green exists to do two things, right? Filecoin Green exists to both apply this sort of thinking to the Filecoin network itself and build tools such that people can use Filecoin in order to back up these sorts of sustainability claims. And so what specifically are we working on? Well, we're building tools and we're building processes to reduce the environmental impact of the Filecoin Green network. We're trying to help storage providers use renewable energy via several different routes. We're trying to put environmental data, store environmental data on Filecoin and allow developers to use that data in their projects, right? Because crypto is so transparent, you should be able to just know what the environmental impacts of an action that you take are if you're doing something in the Web3 ecosystem or in the Filecoin ecosystem or in Web3 more broadly. And we're also aiming to provide new solutions for environmental accounting. And so we'll talk more about that. So, what does this actually mean when we talk about making Filecoin verifiably sustainable? What does that mean? Well, sort of here's my conception of that is this is the Filecoin supply chain, right? So you have all these inputs. You have electricity, that's the majority of emissions of the Filecoin network. You have hardware, storage providers buy all that stuff, and they use that to store data for clients, right? So you go to storage providers, that's the Filecoin logo here. They provide storage. There's a screenshot of FilRep, which is one of the places that you can go to see who is available to store data on the Filecoin network. And clients are, largely Web3 companies that are building and projects that are building on top of Filecoin, so using Filecoin to store their files. And so we are building tools to firstly just measure these environmental impacts, right? So when a storage provider takes these inputs and uses them to produce storage, how much electricity is a storage provider using, for example? And we can tell that. We've done months of research, and we can tell how much electricity a storage provider is using just based on their activity in the network, right? So we can see how quickly they're sealing data. We can see how much data they're storing, and you can go to filecoin.energy if you want to look up those numbers for an individual Filecoin storage provider or for the network as a whole. And there you can get an upper bound, a lower bound, and an estimate as to the energy use, and relate that to on-chain records. So you have these inputs, right? These inputs like electricity come with carbon emissions. They go into the network, right? Storage providers use them to store files. They provide storage, and we're able to see that, right? Filecoin Green wants to make all of that really transparent, wants to allow you to see, if you're a client, you're storing data with a given Filecoin storage provider, what are the emissions due to due to that data storage, right? And we're partway there, right? We have these really transparent industry-leading tools showing what we think the electricity use is, and emissions is something that we're working on. And when people have ideas as to how to make tools better, we want to get in touch with you, and we want to help you build out those ideas. Then the next part of this, right, is we don't want to just measure. We actually want to empower clients and storage providers and other members of the ecosystem to actually reduce their environmental impact. And we're going to be talking some about that. But today we're going to focus on this piece of the puzzle here, right? So electricity, I said, is the primary source of emissions in the Filecoin network, and it is in most crypto networks. And electricity is used by storage providers in order to store files, and that's what we're going to focus on. So how do renewable energy purchases actually work, right? When we say this Filecoin storage provider runs on renewable energy, what does that actually mean? Well, for some storage providers, like we heard from Dissent a month ago, they're actually building solar on their roof, right? So it's really clear if you're co-located with, say, a solar farm, or you have rooftop solar, right? And you're producing electricity at your facility. But most storage providers and just most electricity users in general are not co-located with renewable production, right? So what are the industry standards that handle a situation like this, right? Where you want to buy solar from some particular solar farm, but that electricity is coming to you through the power grid, right? And you as a Filecoin storage provider are using it. Well, so the way this works is solar farms and other renewable energy generators can produce both electricity and what's called an energy attribute certificate. And that energy attribute certificate can go by a bunch of different names based on where you are. In Europe, it's often called a guarantee of origin. In the US, it tends to be called a renewable energy certificate, or REC. You may have heard some of these names. There's an international program called IREC. But they all certify that you're purchasing a megawatt hour of electricity from this particular renewable energy generator, right? And so that's what the industry standard is based on. So if you read on a product, this product is produced using 100% wind energy, say. What they mean is they've figured out how much electricity it takes to make this product. They've bought these energy attribute certificates that match the electricity use of that factory, and then they're able to put that logo on. And this industry standard exists because we want to provide end users a way of financing renewable energy producers, right? So that money is going directly to the solar farm or the wind farm or whoever else is producing renewable energy that you're purchasing. And so that's a great way, right, to allow people to connect to the power grid, right, which is a public resource, and to try to support renewable energy generation through that power grid. But, of course, the situation is more complicated than that, right? So it's not quite as clean cut as there's a wire going directly from this solar producer to your operation, right? So there are other power generators that are not all renewable on that same power grid, and they are producing power not just for you, but for everyone else who's connected to that power grid, right? So this raises questions about what is, say, the marginal effect of emissions on the storage provider's energy use, right? The power grid is managed not knowing about these energy attribute certificates, right? The operator just wants to match the amount of power being generated at a given time to the amount of power being pulled out of the grid at a given time, right? So the marginal effect is much more complicated. And you can figure it out, right? You can get these stats at a particular point in a power grid at a particular point in time, but it's not as clean a story as we're led to believe by this industry standard, which, as I said, is a good industry standard. It just, the story is more complicated, right? And then the next question is, when the grid is stressed, is there enough electricity to go around, right? So this is something that a lot of crypto has been criticized for recently, which is just if the power grid is producing a lot of, or if the power grid is being required to supply a lot of power, right, and crypto is using a bunch of energy, how do we deal with that, right? How do we make sure that we're not causing power outages, say? And so this is all an elaborate lead up to an announcement that we made recently, which is that Protocol Labs just invested about $35 million to build new solar in the US. And so the idea here is that this fund is going to go to finance distributed solar projects. So these are going to be solar projects throughout the US that are going to tend to be on large commercial buildings, so things like office parks or big box retail stores, that type of thing, that are going to produce distributed renewable power all over the country. And we think that this is going to produce about 3.5 times as much electricity as the Filecoin network currently uses in the US, right? So this is one of the ways you can substantiate that you're actually having a positive effect on the power grid, right? When you look at the cumulative effect of the network and this renewable energy that we are providing primary capital to build, right? So we play a role in financing these projects. These projects likely would not have been built without us playing a role in financing them. We're able to say, okay, we're actually really having this positive environmental effect at shifting the entire power grid, which again is a public resource, toward renewable energy. So we're really excited about that investment. And I'm happy to take more questions on any of this. If you want to be more involved in Filecoin Green, you can email green@filecoin.org. You can join the Filecoin Slack, and you can join the #Phil-Green channel. If you want to sign up for updates for events like this one and other updates that come around, you can go to tinyurl.com/Filecoin-green-updates. We're also going to have a South by Southwest panel that's going to be both live and streamed. This is a off-Broadway South by Southwest event. So it's going to be at the Protocol Labs NFT Hacker House on Sunday, 3/13. So, please, watch the live stream of that. Or if you're going to be at South by Southwest, please join us in person. And so the way this is going to work today, we're going to have a few questions that are directly relevant to a presentation right after that presentation. So first for mine, then for Alex's, then for Jim's. Then we're going to turn off the live stream and just have a discussion in the Zoom room that could be questions about specifically what was presented or just general questions for the community or for Filecoin Green. And so if anyone wants to, if anyone has any questions specifically about what I was just talking about, feel free to either unmute yourself and ask. We'll take a couple of questions or type them in the chat. The community is brimming with questions. Oh yeah, and Angie just dropped in the chat the link for the Sustainable Blockchain Summit, which is going to be in Austin at South by Southwest on March 13th.
For outside of US or Europe, so most of the non-green energy is produced there in mostly in developing countries. So for developing countries specifically, what do you look for if they are sustainable or not?
The question is about renewable energy in developing countries.
Yes, and how do you track if they're using renewable energy or not?
Yeah,
outside of US and Europe.
Yeah, I mean, so the overall story, right, is that there's a lot of different ways that you can support renewable energy in given locations, right? And so part of what we're doing is purchasing these energy attribute certificates, right, which show that you are supporting specific renewables installations in specific locations, right? And that's a quicker thing that you can do than building new solar, right? So we're looking at the totality of ways that the network can support renewable energy across the world. And we are tapping into these renewable energy markets through energy attribute certificates all over the world. The fund I just announced was just in the US, but we're looking to build, additional solar or, be involved in wind financing, that kind of thing, all across the world, and doing that currently through these energy attribute certificates. Does that answer your question? Are there any apps being built to help storage providers spin energy usage up and down opposite peak energy demand times? Yeah, that's a super good question, Lindsay. So the tools that we've built so far allow anyone to estimate what the energy use is of a given storage provider based on their on-chain activity, right? So based on how much energy, how much storage they are sealing over time, and how much storage they're actually contributing to the network over time. So then the question is, okay, well, the actual emissions, right, corresponding to energy use vary a lot based on which power network you're on. They vary a lot based on where in a given power grid you are. And they vary based on time of day, right? So maybe if your grid has a lot of solar, maybe during the middle of the day, you have a really low marginal emissions factor, whereas maybe at night, all the fossil plants are what's primarily supporting your grid, and then you have a relatively high emissions factor, so more CO2 equivalent emitted per megawatt hour of electricity. And so I think there's a huge potential, right? And this is something that we're talking to a few different developers to load shift, right? So like, what can we do to help the network consume power at times when locally the marginal emissions factor is lower, or the grid average emissions factor is lower, and allow you to then show, right, that you are shifting power from high emissions hours to low emissions hours. We don't have any tools released to do that yet, but in direct answer to your question, Lindsay, yes, there are some developers that we're talking to who are working on tools that are going to hopefully allow storage providers to do that. And if you're on this call and you are a developer or a storage provider and you have ideas for how to do that, right? So both load shift to reduce emissions and verify that load shifting publicly, we would love to talk to you and help build more options to do that. And so I think that's my time. I will hand the floor over to Alex Altman, who is the COO of Seal Storage in Canada.
Thank you very much, Alan. It's good to speak with everybody here today, and thanks for having me on the Filecoin Green chat. Excited to share with you guys what we've been up to over the last couple months in terms of shaping our ESG standards, and particular focus on our environmental standards as a company. As Alan said, we're based in Canada. We're really a North American operation. We've got operations in Montreal as well as Nevada, with a particular focus on renewable energy data centers that are powered by 100% renewable energy. We've also got kind of a number of different aspects that I'll show you guys from our internal ESG documents about how we approach these various different impacts that we have as a company, and how we can actually plan for the future as we scale. And one of the main elements, and I'll just start sharing my screen now here, one of the main elements that we found out really quickly about trying to deal with kind of ESG and environmental standards and how we deal with that as a company is that there isn't really any clear standards out there. So we spent all this time talking to a lot of the major providers when it comes to how could we be certified, what does certification look like, and we just didn't really find anything that was, comprehensive or seemed to be global enough that made sense to us. So we brought in a number of different consultants who are experts in the field, and we basically settled on a strategy that said, let's just be as transparent as we possibly can in terms of what we're doing from that strategy, what kind of energy we're using, how much energy we're using, where that energy is coming from, as well as as much as we could about what the company was doing and the other elements of ESG, and we could let various stakeholders decide how they felt about that. And how we wanted to start as a company, as I said, is really focusing on, as Alan pointed out earlier, the main usage and kind of environmental impact for Filecoin surrounds energy usage. So we thought our first our first tactic would be go after these renewable energy data centers and build off of that, right? We want to work on what we call our product emissions. So what we're actually doing as a company and the product that we're offering. And once we're able to fully assess that and create something that's fully sustainable, we'd like to move on to the scope 2 emissions, or the business emissions, which would encompass travel for the team members, even so much as shipping off equipment, shipping off hard drives, everything in that scope. But we're definitely still in the first phase, this scope 1. So I'll go over a couple different tactics that we use and a couple different standards that we're looking at as a company. Hold on, I'm just gonna move this here. So, the mission: scaling a carbon neutral, decentralized cloud storage and Filecoin mining. Obviously, Filecoin mining, the name has changed, but as the stock is still in the iteration form, it's there. And our vision is where data storage is reliable, secure, transparent, and sustainable. We want to be part of the future of being able to clean up people's existing energy usage lines. When you look at people's scope 1, scope 2, scope 3 emissions, for those who aren't familiar, that encompasses your entire footprint as a company. Scope 1 is what I was saying before, is a product emissions, is what you're doing directly. 2 is what you cause as a company, and 3 is your entire downline. So in the case of us as a storage provider, that goes all the way to the companies building the storage devices that we use, all the way to the metals that are inside those storage devices. So we want to try to slowly build up to a point where we're a part of somebody's scope 3 emissions, and we're a clean aspect of that, because in order to get to a truly net zero future, everybody's got to have a cohesive emission line. So just here, I'll quickly touch on this in terms of, here are some of the tools and standards that we chose to adhere to. As I mentioned at the beginning, we couldn't find an overall standard that was globally recognized. So here's the various ones that we've chosen to match ourselves to. As you can see, the top 2 are UN-based standards. As well, there's another one, the Impact Management Project, and then the final one, the Global Impact Investing. That's more on the IRIS mechanism, or IRIS metric is for governance, and not as much for the green side of things. But the top 2 from the United Nations, we thought those 2 were the most realistic and global standards that we could try to tie ourselves to. Here for the impact thesis is, we want to be a properly run company from the beginning, right? We started at the beginning of all this and said it's much easier to start with a clean act than it is to go retroactively clean up your company. So we said at the very beginning, what could we do and how could we set these standards for ourselves to make sure that we adhere to them from the beginning and we grow around these standards instead of trying to fix things. And then also taking a look at what these standards meant to us as a company and how did that affect the larger ecosystem surrounding us. So if we're choosing to use data centers that have renewable energy, if we're choosing to use outside resources for things like compute or cloud storage or anything that we need to pull in to continue to run the business, it's understanding what impact those resources have, and then being able to source the appropriate local renewable energy credits, which I know Filecoin Green is working with a number of different parties as well. But what we've also found is that renewable energy credits can be difficult to manage. They are probably best in the marketplace right now. Carbon credits themselves are murky at best, whereas renewable energy credits have a direct calculable impact. But we also found that you have to get something that's local to where you're actually using a non-clean form of energy. So that's another element of what we've incorporated into our plan. So the upstream of what we're trying to do is we're reducing our own GHG emissions, but we're also promoting the growth of these companies that agree with the types of energy standards and environmental standards that we have as a company. And the more that we grow, we become a larger customer there, continuing to create that financial incentive for others to switch to what we're doing. And we've got some other pieces of information here just on our S&G tactics and what we're looking at, and Filecoin obviously being a fantastic source of truth and transparency. So here's another couple pieces when we get deeper into what we're looking at as a storage provider. We've looked at the different categories specifically in terms of what our impact is. This is again all scope 1, so specifically what we're doing as a company. We haven't really been able to dig too deep into the impact of the actual hardware that we're buying, although that's on our list, and something I could talk a little bit about at the end in terms of extending the longevity and how that impacts the environmental ecosystem surrounding Filecoin. But what we've done here is broken this up into 2 elements of the way that we measure this. The first is energy management. There's a couple more standard ways that we look at that, and it's this kind of SASB metric, which is Sustainability Accounting Standards Board, a non-for-profit metric that people can, or I guess companies and corporations, non-for-profits can all assess their own systems against. So that's something where we can learn, existing statistics out there, renewable energy that we consume, where the data sources are, and then we can extract all that and present it to stakeholders. And how we're actually going to do that, we're working with a group here. I think you may have seen the name in some of these slides, called Proof of Impact. And we're actually going to be drawing energy directly from the PDUs in our data centers and projecting that live on our website so that people could see the types of energy that we're using, how much energy we're using, and a historical account of all that energy. Obviously, utilizing, again, that source of truth that I was talking about before that Filecoin offers. I'd say that none of this data has been edited. It was all put onto the blockchain directly, and it's saved on the blockchain so that stakeholders can have an accurate representation of what our energy mixes look like over time, how it's improved, how it's gone better or worse, whatever that may be. And so we're using that metric for that. And you may notice a couple NAs there on the right side from metric catalog. These are actually metrics that we're working to come up with. And that's surrounding the actual energy impact based on Filecoin mined or Filecoin earned as a storage provider. So there's a couple different items that we're considering. We have to consider, how Filecoin Plus applies to this, time of day this is earned. Is there changes in terms of when coin is earned, day or night, based on when providers are operating more or when things are being added on. So we're actually trying to come up with a kind of energy associated number for these different metrics about how Filecoin is mined and how specifically we could look at the energy attachment to each Filecoin as we do that. So what's the specific impact on what we've done beyond just, here's the total energy we use. So trying to kind of make it more of a micro thought there. And the next element is just the GHG emissions I've mentioned a couple times, scope 1, scope 2. We're really working on the scope 1 right now. Once we have our setup done with the PDUs to collect the direct energy usage, and we can make the accurate assessment on what our energy usage is now, we could start moving towards what that scope 2 is going to look like. And we're lucky, since we're a decentralized office, we don't have a lot of travel to and from that, so it's not going to be too difficult. But it really does come down to some pretty interesting things, like if you shipped out some office supplies to somebody, how much GHG was used on that FedEx route to get there. So that one I think is going to be interesting to get there, but we're making a lot of headway here on just assessing specific impacts of us as a mining operation and what these coins that we're producing actually do, both from a GHG and from an energy perspective. And the final slide I want to show with you guys here, and then we can open up for some questions if people are interested, is, again, going back to the point that I've made a few times, was the fragmented market of reporting and standards and people to actually give those certifications. And the closest thing that you could get to standards are the ISO standards, which are the emission standards that the UN has put out, which are hundreds of pages and extremely complex and quite honestly a little bit dry at times to understand. So for us, we're really trying to say, okay, how can we make this circular metric that the data that we're collecting and that we're presenting continues to incentivize good behavior on our side of things. And we want to be 100% transparent with the reporting here, and that's what we're doing with the PDUs within the data center, so we could get our segment of energy used, and we could assess that based on how much we've specifically done within the data center, opposed to just this is what the data center used. With that data, we could see how it's performed against the internal metrics we set, some of which you saw above there, so we can continue to report transparently to both the public and private about how we've been able to perform with these metrics. And then as we continue to either meet or exceed these metrics, we can continue to grow those metrics and improve as a company. Again, the kind of next piece of that is the data collection aggregation. It's all these elements of once we've collected the raw data, it's presenting it. We're going to be having with partnership with this proof of impact company, we're going to be having a dashboard on our website for everybody to review, so that it's any stakeholder within the Filecoin ecosystem can go there and see all this data that we've collected in a nicely visualized way, to in hopes that we could set the standard not just for ourselves but for other actors in the Filecoin ecosystem, how they could potentially perform and compare against us, so that we can act as a benchmark alongside. I know what you guys are building at Filecoin Green there, Alan. We're trying to do that as well, and just add some metrics there for people to take a look at. And then the data verification, as I mentioned before, all the data that we're collecting is going to be directly transmitted onto blockchain and stored on blockchain. So that there's that trustless verification that whatever data there is, good or bad, we can't get around that. So we have to be kept honest there. And if we see problems, then we can improve on those problems. If there aren't any problems, then we're happy to brag about what we're doing. But it's really just we want to use blockchain for one of its main functions, which is creating transparency and a trustless system for people. And then this final piece, even though it's a circle, but it's the analysis that people can take a look at what we've done, how do we do it. If they want to take our ideas, we're happy to share them in terms of how to improve and different things that we've done to get to where we are and trying to be that best in class provider there. So they continue to analyze that data. I know one of the questions that was just asked, Alan, in terms of usage of power at night and during the day, and this data analysis can help us as a company understand not just our costs, but actually are there more efficient ways to be earning Filecoin using our resources by analyzing the data that we collect. So that's kind of the general idea there in terms of what the process that we've set out as a company. We're well on our way to achieving a lot of that, and it's become a significant mission from the beginning of Seal Storage, and we're about a year and a bit into the project now, and we're excited to keep innovating and improving on all this. And that's a bit of information. I think there's about 5 minutes left. I'm not sure if anybody has any questions about methodology or how we got here, what we're planning.
Yeah, feel free to drop questions in the chat or raise your hand or unmute yourself if you want to ask anything.
Talking more about the SASB standards. Yeah, let me stop sharing my screen here. Yeah, I mean, I'm not quite as familiar with them. I know it's a standard that was published about 11 years ago. It's a non-governmental body, and there's kind of no legal obligations to adhere to them. But it's just a various set of rules that you can kind of look at and say, like, here's a way to try to standardize. Like, if you measure, in this type of kilowatt hours, megawatt hours, like everybody has to have the specific types of standards that work well together, so that everybody's trying to row in the same direction, at least compare notes, apples to apples type analysis. I mean, the rest of it, though, I'd have to say I'm not too deep in that. My side of things at Seal is really trying to get more of the broad goals in terms of the in-depth analysis of how we're able to track that. There's a certain level of expertise that I don't currently possess, but I do know that the SASB is, it's promoted a lot by Deloitte and used by many of the big four accounting firms. So we're quite comfortable with some of those standards. And I guess there's another element that we're looking at as a company, and I think it's going to be a big push for us once we're able to get the dashboard up and running. Something that we've been really taking a look at as a company is, you could do a lot with renewable energy and reducing your GHG emissions, but one of the absolute best ways that I think Filecoin can actually improve overall emissions, that is an area that we're looking to explore and try and analyze, is because you can keep older machines for longer because they're profitable for longer. You could actually significantly reduce e-waste and the emissions associated with e-waste. And I actually think that area might be one of the largest, if not the largest, impact that Filecoin can have from an environmental perspective. That's a relatively large undertaking, but I mean, for us, we think we can likely extend out the kind of not even useful life, because people tend to throw out these machines when they become less profitable than just buying new ones, but the profitability of the machines by a couple of years. And if you could reduce e-waste anywhere from 10 to 25%, you can cause huge environmental impacts, not just from an emission standpoint, but also toxic chemicals and mining, and there's all the S&G that's associated with that, because a lot of these minerals are potentially conflict minerals, or they come from areas with lower environmental standards. So that's an area of growth for us, and we're starting to explore that now, and we're going to be working hard to quantify what that what the specific numbers are, and we could share that with the community once we've made progress.
Yeah, I think two really important things to highlight are firstly that, right? When you think about Filecoin, being a Filecoin storage provider versus like a Bitcoin miner, right? With a Bitcoin miner, your profitability is super closely tied to what exactly the price of energy is and precisely how efficient your hardware is. And so I think this e-waste point is really well taken, that with Filecoin, you invest in a bunch of hardware, but you're using it to seal over time, and like energy use is not as high a portion of your operating cost, or like the overall capital structure of like a Filecoin mining operation, which like very much, as you're saying, changes the game in terms of how long your hardware lasts.
It's that, as well as with the increase of storage density, right? If all you're doing as a storage provider in a non-blockchain world is selling storage, it makes a lot of sense to just keep buying denser storage every 4 years, because why would you bother taking up rack space and energy when you could just buy new storage and then you kind of make that economic factor into yourself as a company? But if you're able to almost subsidize those older machines and keep data on them because there's still block rewards associated with that, there is an economic reason to keep those older machines on the racks, even though they may be not as energy efficient as new machines. It's still significantly better than having to create an entirely new machine. So I think that's another area beyond Bitcoin mining, but I mean, just extending older machines for conventional storage providers is an exciting area for us to explore.
Yeah, 100%. And then I think also something else that you mentioned that I really want to highlight is, making actual data from your PDUs available so people can really see like what are the actual electricity measurements, right, as a function of time, like over the course of a day or a month or a year. That's just such a higher standard, right, of transparency than exists in Web 2 right now, right? Like when you go to Google, like you don't see the PDU, right? So as much as we can do to like really tie statements about environmental impact, like you're doing, to not just average measurements or not just overall measurements or sort of a big picture or a glossy PDF, but like actual real underlying data, I think that's gonna just really upgrade our ability to make these environmental claims in a way that is transparent and verifiable.
Absolutely.
Awesome, great, thank you so much, Alex. If you can stick around afterwards at all for discussion, people both you and anyone who's on the call who has more thoughts or questions, that would be great. I think now we're going to move to Jim Pick, who is a developer who's been working on this question that is really at the heart, like I was saying, of matching energy use in this distributed permissionless network to renewable energy, which is that you need to procure renewable energy that is not just renewable, but it needs to be procured at a given place and at a given time that is matched with the the energy that you're consuming, right? And so there's this huge question, right? If you have this distributed network that has all of these different nodes on it, and we know something about how much they're using, we need some idea where they are geographically in order to match them with renewable energy. And so this is, this question is really at the intersection of two fields that are rapidly evolving, right? One of these fields is just how do you make really high quality sustainability claims about renewable energy, right? And standards for that, I'm thinking of things like the shift to 24/7 renewable energy. Those are being debated and upgraded right now. And then on the other side, you have the whole field of power use in distributed systems, right? Which is very much an area of academic research right now. And they sort of collide, right, at this point where you're trying to imagine, okay, how do we take this distributed system where we have little nuggets of information about geographical power use, but not the whole picture? How do we make an effort to really match that to renewable energy at a global scale? So Jim, take it away.
Thank you. I'm going to share my screen here. Okay, so my name is Jim Pick. I live in Victoria, British Columbia, Canada. So just sort of on the West Coast, just across from Seattle, where Alan is. And I've been freelancing in the Filecoin space for the past 2 years, but prior to that, I was actually working at Protocol Labs, and I was first on the IPFS team, and then I was actually on the Filecoin team for a small period of time where I worked on some of the libraries so you can use JavaScript to talk to the Lotus node. So since I've been freelancing, I started, and the Filecoin network launched, I started collecting a lot of information from the Lotus node that I was running and trying to pull it into databases and try to make sense of all the activity that's happening on Filecoin, partly for my own understanding, but partly because I need this sort of metadata that comes out of the blockchain to be able to successfully make deals and find providers and store files on the network successfully. And I'm really interested in using Filecoin as a storage medium, and I'm not approaching it as a storage provider where I'm trying to put hardware on and earn block rewards. I want to use it as a client. So I've created this open source project, and you can access it if you just go into your browser and you just type provider.quest. I've registered the domain name, and it'll just redirect you to this platform called observablehq. And it's a platform where there's a large community of people who build visualizations using JavaScript. A lot of data science and visualization people are here. And if you go to the site, you can see all the different notebooks I've been putting out there. And I'm also publishing a lot of data that I'm generating out onto the IPFS network. And I encourage people to take this data and try to build applications with it as well. So, so this is my project. Just like every day I go in here and I look at the published deals, and in real time, I'm tracking how many files are being or deals are stored on Filecoin, how many files there are. And so I'm tracking I'm pulling in several different types of information. So the main thing I'm pulling in is power information. So every hour I'm scanning in every single storage provider on the network, and I'm storing their power into my database. I do this by connecting to a Lotus node I'm running, and I'm pulling in the power. I'm also pulling in all the deal information. So that's the information you see here. So this is updated hourly. You can go. There's an hourly view here. You can see it. But what's relevant to the talk today is I'm also pulling in location information. So the thing to understand with Filecoin is there are sort of like two types of providers on the network. And I'm going to pull in there was a blog post. If you search for the Filecoin blog for block rewards, and at the bottom of the article, there's an article about the stages of Filecoin. And so you can think when Filecoin launched in stage 1, there was a big land rush. Everybody set up their operations, and they put tons of computers on, and like there's actually like millions of hard drives hooked up to Filecoin, and they're all going for block rewards. So they put these machines on the network, and they want to get block rewards. As the network matures, it's going to be more for people like me who want to store files on the network. And that's about deals. So that's, can I send files to a storage provider and retrieve them back? So for stage 1, for block rewards, it's all about putting capacity on the network. They have to put the hard drives on the network. They have to continuously prove to the blockchain that their machines are on the network. And then they get block rewards, which are worth money. You know, the Filecoin token price could go up. That's what everybody's banking on. So there's a big land rush. But all of these storage providers, there was no requirement for them to actually advertise their location. So if you look at if you take all the different storage providers out there, more than half of them right now, I'm not exactly, I'll show you. So I have a visualization here. If I click on Sunburst here, I'm gonna just turn that off. It takes a second to load because it's pulling in a lot of data here. I hope it works. Oh, there it is. So, okay, so maybe I'll just shrink this a little bit. So you can see this is the current power of the network. So there's 15 XP bytes, I guess that's how you say it. And of all the power that's on the network, this much power, if I just go by looking at the IP addresses of the machines associated with the storage provider addresses, I don't have an IP address for them, so I can't geolocate them and find out their address. So, and the ones we do know, we have a lot. So this is going by power. I can also look at this by provider count. It's a slightly different. So the really big providers that have like hundreds of thousands of hard drives hooked up to them, a lot of them, those are the ones that aren't making it known where they are. And so this is a really big problem if you want to buy energy credits, because where are they? Like, and so all the rest of these, we all have IP. So we've actually got IP addresses for more than half of the providers on the network. But if you look at the total, like the hard drive usage, it's, well, 2/3 of them, we don't actually have information on where they are just by looking at the IP address that they're, now the reason they would put their IP address, advertise it to the network, is because they want to get deals. You can't communicate with them on the internet to say, I store my file, retrieve my file, unless they make that available. But if they're only interested in getting block rewards, it's not really a problem for them. In fact, it might actually be a good idea for them not to put their IP address on the network, just because that opens you up to, hackers and denial of service attacks and that sort of thing, which could impact them trying to make their block rewards. So maybe all of these providers are just being sort of smart. Maybe they're doing sort of like a game theory type of thing, like they don't want, it's a permissionless network. They don't really want to reveal their cards, their poker hand, to the rest of the network. But as the as the network moves into stage 2, there's going to these providers are going to want to decloak themselves. They're going to want to make themselves available because they're going to want to store Filecoin Plus deals onto their machines, into their storage provider. So today there was the OSNAP upgrade, snap deals. So all of that storage that's been proved to the network, they can now put that online. If people store data into it, they get 10 times the block rewards. So the economics are going to change. We're moving to stage 2 here, and a lot more of those IPs will become available. So, but we still have this problem. So it's like, okay, where are these? Like we want to know for Filecoin Green, where are they actually located? So just going off the IP addresses, we have no clue. But we do have a lot of blockchain information, and there's a project that Protocol Labs runs called Sentinel. It's a piece of software, and then what they do is it's a historic archive of all the blockchain data that's ever been recorded into Filecoin, blockchain coded into the blockchain, and you can download it, and it's all on Amazon S3 in this historical data dumps directory. So what I can do is I can actually, I can't use the IP information, but what I can do is I can look at the funding history. So when you create a storage provider, a miner, when you create a miner on the network, you have to put some money into a wallet address on the network. You put some Filecoin in there, and with that, you can create your storage provider. And so every single storage provider that's on the network originally was funded by a Filecoin address with some funds in it. And every one of those Filecoin addresses got money from somewhere else. They're initially funded. And then if you trace it all the way back, right back to the genesis block of the network, when they started the network, there was a whole bunch of storage providers that were initially seeded in the very, very beginning of Filecoin. And so we can build a tree. We can look at like, this address was funded by this address, was funded by this address, and some of the addresses funded multiple addresses. And a lot of these addresses are not used for storage providers. A lot of them are just for people investing in Filecoin or playing, buying and selling. But we can just filter down the tree and just look at the ones that were in it. So okay, I'm gonna have to go faster. So what I've done is I've taken a look at this funding tree. And what I did was I processed every single transaction that's ever happened on Filecoin from these data dumps. I'm able to construct a tree like this, and I can look at each service provider. And if you look at this tree, you can sort of look through here and you can sort of see when you go down some of these branches, oh, they're all in a very similar geography. And so I built a tool where I can look at these geography or look at this funding tree and mix in the information I know about, like from IP addresses, but then some of them I don't know. So I'm going to quickly show you a test case I have. So I can look at subtrees of this big funding tree. You can see here's a small subtree. This address funded these addresses, and some of them are storage providers, which happen to be in China. One's in Hong Kong, but some of these I don't know where they are. I can click on them, and if I click, so say I like to click on this one, I don't know where this one is, but if I go up here, I can see this other one is in this location. And so I can just start mapping these, and I can say, okay, this one is probably the same as this one, and this one's probably the same as this one. I can look at, say, a more complicated tree, and you can say, okay, these ones I didn't know where they were, but now I can sort of guess, and you can say, hey, they're probably in Shanghai. I can look at another one here, and here's one. This was Japan and Russia. So there's all this capacity that's been proven to the network. I didn't know where it is, but now I can sort of make a pretty good guess of how it works. So I'm running out of time, so I'm just going to show this with some reporting. So I spent a month working on this, and I just got it working yesterday. So I can go back to go back up here to the sunburst. Oh, there it is. So sunburst. So with the synthetic regions now, I can say I don't have this big section that was we don't know where they are. I can take all of these ones where we don't know, and we can map them onto existing ones we know based on this funding tree. So now if I look at the entire power of the network, it's like this, and then we can actually drill down into these. So we can go into like Europe. We say, okay, most of the power is in Germany. Let's say you want to go like Northern Europe. You can say, okay, Norway. We don't have these big unknowns, and let's see, I think probably I can also go into this thing. I can like go by country, and now I can. It's good if I start up 2 windows here. So we have this data broken down by country and state. So I'm going to do say like California. So if I go US, California. So if I do it without synthetic regions, you can see we've got 16 petabytes of data. And but if I use or if I use the synthetic regions, I do down here, California. I've now mapped an additional bunch of these providers, or we didn't know where they were, but there's a good chunk of them are probably in California based on this funding tree. And now we have 140 petabytes. So we've gone from 16 petabytes to 140 petabytes. And this is not guaranteed to be correct, but it's probably proportionate with the information that we know. And it's probably, when you do numbers in aggregate, this is probably not far off from what it would actually be. So, you know, for California, oh, I'm looking at the wrong one here, sorry. I'm do apples to apples, okay. Okay, this is better, okay. So 70 petabytes here versus 140 petabytes here. You can see I've got like 30 plus miners here. I've got like 55 plus miners here. And it's gonna vary depending on some regions. We can see in the funding tree, they're really sort of tightly packed together, whereas in some other regions, it's scattered all through the tree. And that's going to affect sort of like the ratio of how we map these things together. So anyway, so I have this data that I just got this working yesterday, so I don't have enough documentation. It's a little hard to explain it, but I'll leave it at that. And if you have any questions, I encourage you to come and talk to me and play with these numbers. And I'm going to try to get all the data really published out there, so anybody can use this numbers for their reporting.
Yeah, thank you, Jim. I really want to underscore, right? It's like, this is an issue in the Filecoin network, but not just in Filecoin, right? Like as renewable energy in permissionless distributed systems evolves, right? People increasingly have these questions about like, how do we actually take this global network where we have these like bits of information and actually connect it to renewable energy in a way where, you know, the renewable energy purchases are proportional to where we think that power is being used, right? And some storage providers, like Alex was just talking about, are on board with being super, super transparent and, you know, revealing their location and their power use and getting all of that audited. But then there's a ton of storage providers where, just to make a good faith effort, matching renewable energy to matching energy consumption to renewable energy production, we really need to like dig into the data that we have and try to figure out sort of forensically, you know, what do we think the geographical distribution is, right? And that's going to be relevant to all these other networks too. So I was describing this problem to Jim, and, you know, he had this idea that I think he had been thinking about for a while with these funding trees. And I was sort of amazed he was able to come up with something like this. And then I think he said that his dad is a detective, or was a detective. So I guess it runs in the family, is like the conclusion I had. But yeah, if people have questions on this, feel free to drop them in the chat. Then we'll go to a general discussion. Awesome. Well, thank you so much, Jim, for talking about this. Actually, it looks like Beltran has a question about synthetic regions.
Yeah, so the synthetic regions generated from the tree, yes. So we use the tree information combined with information we know about IP addresses for the providers that do have IP addresses. We combine it together. And then for the ones in the same part of the tree where we can match them with the with IP addresses, we can, I call them delegates. So they delegate their locations to another one in a very sort of consistent, use a technique called consistent hashing to map them together. And this gives us the ability to not just randomly assign them, but we're actually looking at the structure of the funding tree to intelligently map. Like this one we don't know about, but we know it's been funded with common ancestors to these other ones. So we're going to map the locations using these delegates in a very consistent sort of way. And it's only information we really have, so it's sort of the best we can do with the information we have. But with this algorithm, we can assign everybody an address, a location, even if we really know nothing about them other than their funding history. And that location it's just a guess. It's not going to be accurate 100% of the time, but the theory is that it's going to be mostly accurate. Like if you're doing high level reporting where you mix all the data together, for like Filecoin Green, it doesn't need to know specifically where everybody is. It would be nice to know, but in aggregate, it should be pretty accurate. So more accurate than just guessing. So this is awesome. Would it be too much to ask if you could show an example since your tool seems too powerful? Okay, can you explain some more about what info is in the funding tree? The funding tree is really simple. So it's just basically, like if we go, this file is so big in my browser. So if you look at the genesis of Filecoin, when you have your you put your funds in a Filecoin address, it's this big long string, but people don't know each one of those long strings with your like F01 or F03 or F1 or F3 also has a short name like this, so I can use these short names, and these are all wallets or wallet addresses. And so this was actually the genesis block. F0110, and at Genesis, all these different addresses were funded, and each of those addresses, so like this address was funded, and then this address was used to create this other address, which happens to be a Filecoin provider or miner, and it was funded from funds it initially got. So we can see that this one Filecoin providers can be in multiple locations depending on how many addresses they advertise, IP addresses. So we can see this one was in China, in Fujian. Here's a different one. It's in Germany. And so this is the only information I'm really using to build the tree. It's just like who initially funded all of these addresses, and then I build the tree out of that, and then I mix in the location information I know. Yeah, and Alan's posted a link to the test cases, which you can play around with the matching algorithm. Okay, Ashi, how far back do you go to predict unknown location in the funding tree? Some predefined number of levels till you find a location. Does the level at which you make a prediction impact accuracy? Yeah, so maybe I'll click on the funding test cases. It'll basically go back as far back as it needs to. So, if I click on here and I click on this one here, so I clicked on SP. It's probably really small. So I clicked on F013514. It says first ancestor with region data. So it goes back to this one. And then once it goes back this far, it has region data here. So it won't go back any further than that. And then it crawls back and it sees it only has this one region that is below this node. But if I go click on, say, for example, this one, it actually has to hop up right up to this level. So it says first ancestor with region data is this one. And now it's going to include two possible delegates. So this one here and this one here. So I have to click on it. So, and they have their the power. So one has like 4 petabytes, one has 3 petabytes. But then I have to modify the power to scale it up to give them proportionate to the amount that their portion of the tree has. And so I calculate a fill factor and then I scale the power up. And then what I do is I selected this one, I hash that provider ID, and it gives me you can think of it as like points on a circle, and then I pick one of these based on that. So that's called consistent hashing. That lets me, it means the numbers don't jump around a lot as I update the numbers over time.
Awesome. Thanks, Jim, for talking us through that. And like, I know you haven't written out documentation, but the examples and UI that you've already built are, I think, super compelling. And like, you can really sort of dig into these trees and see how the algorithm works, which I think is great. I think it's like a huge contribution to not just, Filecoin, but also, it's sort of a proof of concept for how you can build, sort of location, you can get location information that is representative of a network, even without total transparency into how the network is distributed.
Yeah, well, I'm gonna write up a blog post and add some more documentation. I just got this all put together yesterday, so
yeah, that's awesome. Thank you.
It's like it all works too much.
Sweet. Okay. Yeah. Thank you all for coming. I think that concludes the part that we're live streaming, and is going to go on YouTube. So anyone who wants to stick around and just have a discussion and